This is SciByte, episode 86 for March 19th, 2013. Hi everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science, news, and information podcast, live every Tuesday night over at jblive.tv and fresh Wednesday mornings over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
Okay, what are we talking about today?
Today, we're going to take a look at exoplanet atmosphere, HIV-killing bee venom, ancient sundials, viewer feedback, spacecraft updates, curiosity news, and as always, take a peek back in history and up in the sky this week.
Heather, that sounds so fascinating I can't cram it into my ear holes fast enough. Well, what do you say we kick it off with the news? What do we got in the news segment today, Heather?
All right, taking a peek at an exoplanet's atmosphere.
Ooh.
Now, we've talked about this before, but in the past, it's always been, when a planet passes in front of a star.
Right.
You can kind of read that. No, this is actual direct observation.
How do we pull this off?
There is a system, the multi-planet system, that there are 3 gas giants orbiting around this star.
Okay.
Now, it's kind of like a super scaled-up solar system, about 130 light years away, but the planets are so hot and they're far enough away from the star that if you block out the star, you can actually be able to read the light from the planets.
Oh, no kidding.
So you're able to make a direct observation about that specific planet.
They stand out on their own, as it were.
Yes, exactly. So now they've found hints of ammonia, methane, carbon dioxide, acetylene in this atmosphere. And it's the sharpest spectrum that they've ever seen or been able to read off of an extra solar planet.
Right.
So they're kind of using all of this now to look at, they've been kind of inferring the existence of these exoplanets by their gases, changes in the light streaming from the planet's star.
Mm-hmm.
But now that they have this, they can actually shed light on how planets are formed, give us a much better idea of the details.
I guess they get a whole new set of data when they can see it directly, and it's not sort of like this. I mean, the word that comes to my mind is probably not the right word to use, but I want to say third-party observation, where you're not directly observing the object, you're observing the object's effect on another object, and then inferring, say, well, okay, if we know X about the object it's affecting, then we know it must be made of Y in order to generate that effect. And so we can then, if we know it's made of Y, we can assume these things about it. But now we're actually taking a direct picture and looking at the details of whatever data they can pull from that. So it seems like it's kind of like you're going from we can kind of assume and project to more like we actually know. Do I have that right?
Yeah, actually, and it's kind of funny because so much of this extrasolar planets and this astronomy stuff is taking 3 little tiny bits of info and working backwards and forwards from all of that to get all this, what you called it, third-party information. Mm-hmm. But this is one of those times where we see it directly. So we're able to kind of make calibration data and be able to make a lot more specific and refined, observations and analysis from that data. Mm-hmm. So now they can actually, and there's 2 different studies that were able to do this. There are a couple different planets, 3 or 4. And with one study, they kind of they're able to get a analysis of all the planets. So they kind of looked and said, okay, we see carbon monoxide, water, we don't see methane, but it might be there. And a different research study was specifically on one specific planet. So they have sort of 2 studies going in it the same way, and they see very similar stuff. So they're not contradictory.
Mm-hmm. Which is good. I mean, it sounds like they're on the right track then.
Yeah, exactly. Now, so by looking at this, you can actually, there are 2 main planetary formation theories. One, gravitational instability, which means there's a whole bunch of gas and dust, and suddenly it starts clumping up, just sort of randomly collapsing, and then, coming in on each other. But then in that case, the chemical composition of a planet should pretty much match that of the star because it's just sort of clumping together the same way as the star did almost. And then the other model is core accretion, which means they're kind of built in two steps. First, material kind of accumulates into a core, then the core captures gases swirling, and that's how an atmosphere forms. Now, in that case, the ratio of, carbon dioxide, oxygen, or other things would maybe different because just the way it forms is the core would be similar, but the atmosphere would be pulling off different, ratios of stuff. So they're able to look at these planets and so they're able to see such detail. They're actually saying, okay, well, if we can get just a little bit more data out of this, then we can say this planet was formed versus in this way or that way. So this specific planet seems to have a little bit more carbon related to oxygen. So it kind of says that they think that this specific planet formed via core accretion, which is, where, accumulates into a core, then it captures gases. So they're thinking that because of that direct observation, that when the disk formed around this star, maybe water froze into a whole bunch of particles, into ice, then a little bit of the ice collided and helped form the planet's core, which meant there was not a lot of water vapor out there. So less oxygen. And then when the planet, sucked in atmosphere later, there wasn't a lot of oxygen to be there. It's all as formed of ice in the core. Now, of course, scientists don't always agree. If you ever wondered, not everyone always agrees in science.
And honestly, I'm kind of glad they don't. It doesn't.
Yes.
It would not benefit the rest of us if they always did.
Oh no, not at all. So not everyone obviously agrees. They're like, I don't know, that's data, but I don't know if it really tells us anything for sure. So, but
I feel like honestly, it's good to question, and I'm not.
Well, yes.
I'm not going to critique that, or even assume that I have any basis to. But what I would say is, I feel like it's a little short-sighted because when you tell me this, I think of. I think we take for granted sometimes how cutting edge our ability to do this is, and the sci-fi Star Trek fanboy in me hates to admit this, but the reality is, for at least many generations, many generations will ever be listening to our words, this is how we're going to explore space. I mean, beyond our solar system. This is going to be, it's not going to be sexy. We're not going to jump in starships. We're not going to have warp drive. We're going to have amazing data and new ways to remotely determine things based on our understanding of physics and science. And we're just really at the absolute beginning of our adorable ability to even do this. I mean, we have to kind of remember this has only been going on for a couple of generations. And so, well, yeah, sure, they can question it now. This is unquestionably the direction that this science is going to be going. And, what's fascinating about that is it's not, in some senses, as limited as actual space travel, because you can have thousands of scientists here at home working at a station doing this kind of science and making these kind of discoveries where you can only have small amounts of crews and funding to send actual spaceships. So I think it's actually pretty exciting. And even if there's people who dispute it now, I think we'll just have more evidence to support it down the road.
Yeah, I mean, look at what is fact, what is fiction, and what we were able to do in the last 100 years.
Yeah.
I mean, going to the moon? You're crazy, man. What are you talking about?
I mean, flying. Okay.
Yes.
Flying has not been that big. It took us. What was it? We went from not being able to fly to dropping the H-bomb in 100 years, and then after that, we were shortly into space, and we've moved on, and now we've launched satellites, and we're observing the makeup of the atmosphere of planets that are how far away? I mean, it's incredible.
120,000 light years away.
Wow. See, now.
Well, 120 light years away. But still.
I don't care what warp factor you're going, that's going to take a while.
Yeah. But it is interesting because you can move so quickly, but you do have to take a step back. I mean, we've seen a lot in the news or various papers where somebody comes out and then, oh, wait, never mind. Huh, scratch that.
Mm.
So it's always good to, argue about this stuff. But because, every time we discover one of these exoplanet systems, we're like tweaking the model. And occasionally it completely breaks the model. Every once in a while, I'll be like, yeah, guess what? We found a planet that orbits around 2 stars. This is nuts. We didn't think it was possible. And now there's multiple. It's where we thought planets could definitely wouldn't exist. There's no way. And then they are there. Then we find others that are there. Yeah, Hemi in the chat room says, that's what it is. That's what science is. Trial and error.
Yeah.
Yep.
Trial and error and then consensus on the results.
Yes. I said it before. I like the saying, the great science discoveries aren't generally, don't follow Eureka, but more like, huh, that's weird. So you see something, you're like, huh, didn't expect that. Let's try that again.
Absolutely. Well, any other thoughts on that story?
No, don't think so.
All right, then let's take a pause right here and say, hey, everybody. Hello, everybody. You know what you could do is you could think of us before you shop over at Amazon or Newegg or ThinkGeek or Best Buy. Go over to JupiterBroadcasting.com, and if you scroll all the way down to the bottom of our fantastic website, you have down there. In fact, you know what? While you're at that website, why not right-click on one of those great new episodes and open that in a new tab and listen while you shop? That's what I would do. Anyways, while you're down there, Amazon, say you click on that. If you click that before you shop, a portion of your shopping session will be contributed to Jupiter Broadcasting. That's sort of our secret sauce. That's how we pay for the bandwidth. That's how we kind of keep growing with our community, because the philosophy is the more viewers and listeners we get, the more people clicking in those links, and it's sort of an organic match. It matches our expenses. Hopefully, anyways, but we need everybody to participate. We also have links down there for your browser extension. So for Chrome or Firefox, you grab those, and it'll automatically take your shopping session, not just for the sites down there, but for additional sites that we don't even have listed down there because, well, there'd be a lot of sites, like great sites like Monoprice, for example. We also have Opera and Safari extensions coming soon. But this week, we're going to have links in our show notes for 2 great picks. The first pick is Heather's suggestion, which I think I'll be picking up myself, so I'll be using the link in the show notes, and that's The Hobbit. And you have the Blu-ray version here, Heather.
Yes, I have that one linked just because you can get to everything. I'll probably do the digital to start with.
Well, the Blu-ray comes with the digital and a DVD version, so that's kind of sweet.
Oh, yes.
That's kind of neat. So we'll have a link to The Hobbit if you want to grab yourself that. And the one I will have linked in the show notes will be for the PC, but if you click that link and then grab the Xbox or PlayStation or whichever version you want, the box set, whatever, we still get credit. But the link in the show notes will be for the PC download edition of BioShock Infinite. We have,
yes.
This is the season pass that I have here, but there's a few different versions of BioShock up there. And I'll link to one of them, and if you want to grab yourself the pre-order of BioShock, which is honestly looking pretty good, just use that link and then pick the one you want on Amazon. See right here, Heather, I'm kind of tempted to get this game, but it doesn't work under Linux, so I would have to boot into Windows or load up my Xbox. But have you seen where they're like up in the blimps and it's all steampunky?
Yes.
Mm-hmm.
Yeah, I've been watching the videos off and on. They've been coming out for a while now.
Mm-hmm. That's kind of what I want.
Scooting along railways and up in the air. It's crazy.
So it's out on March 26th, so if you want to grab it on pre-order from Amazon, just use the link that we'll have in the show notes. And then either go to Amazon and grab the edition you want or just grab the one that we link, and I'll have the PC version linked. And then we get a portion of that. And that's a nice way to get yourself something, but also support the content and the programs that you love. And it also keeps us from having to go to sponsors and fill our shows up with any kind of sponsorship that we could possibly sell, which is great for you guys too. All right, Heather, with that out of the way, what do you say we move on to the News Bite? What do we have in the News Bite today?
All right. Bees. They are the enemy of us and HIV, apparently.
Ooh. Okay. So I was about to say I hate bees, but now I'm like, all right, what you got?
Yes. So there are nanoparticles carrying a toxin found in bee venom can actually destroy HIV while leaving surrounding cells unharmed.
Wow.
So this isn't necessarily a medication. This is something for topical, sort of.
Okay.
So the bee venom, it contains this potent toxin named melittin, and it pokes holes in the protective envelopes that surround HIV and other viruses. This one shows that you can actually load it into these nanoparticles and they won't harm normal cells because it has like little bumpers, essentially like little things sticking out.
Hmm.
And the gap is too small for normal cells. They just kind of bounce off. But HIV cells slip right into the parking space and then they get dead. And that it's actually able to attack the part of the structure so instead of inhibiting the virus's ability to replicate, which is most drugs do, this just kind of, essentially pops the balloon and it just kind of deflates and dies. So it's
a nanoparticle, huh? With bee venom.
Yes, with bee venom in it. It's not stopping an infection. I mean, it's not stopping the initial infection, but
it's sort of blocking it from spreading because it's taking the connectors that HIV would use.
Kind of.
Filling them up.
Yeah.
Kind of like what caffeine does for the receptors in your brain that make you think you're tired. Caffeine doesn't actually provide any energy. It actually just prevents certain things from connecting in your brain that make you feel tired. That's why a lot of energy drinks include a lot of sugar and vitamin B12 and things, because that's where the actual pickup comes from. So it's kind of like that, right? Where this nanoparticle loaded with this bee venom is coming in and it's blocking the receptors.
Not just blocking them, but it destroys the cover of it. So it literally pops the particles.
Okay.
The virus.
Oh, okay. Oh,
so it destroys it.
So they're leaking out all their stuff too, and they're collapsing basically.
Yeah, they collapse. So it works with other viruses, maybe like hepatitis B or C. They all use these kind of protective envelopes, and that venom is what pops that envelope.
That is crazy. I see. Right.
So it's more like preventative measure to stop sort of initial infection. Does nothing to treat it. Now, pros and cons. There are some viruses, some strains of it that have found a way to get around it, that completely ignore it. But the pro is that even if those change or certain strains are drug resistant, it still works the same way. As long as it's not smart enough to dance around it, it's treated the same way. It comes in, the protective envelope is there, it gets popped, it's dead. It doesn't matter what strain it is.
Seems like that could apply to a ton of stuff.
Yes.
Yeah. Huh. Well, that's awesome.
Yeah, so bees, you can look at one and you can glare at it for a long time and then give it one okay, dude.
Right, thanks, buddy. All right.
One quick thumbs up. And that's it.
Yeah, but it doesn't count if it stings you because it's not. No. It's got to be put in these nanoparticles.
Yes, the bee venom isn't good. It has to be with nanoparticles.
All right.
So it's a combo.
With that bee science filed, I say we move on to the 2-Byte news. I had so I got the band dinner tonight. And,
you did?
Yeah. So they stuck around, and they'll be here for the post show too.
Okay.
What do we got in the 2-Byte news?
Alrighty, we got the world's oldest Egyptian sundial.
Aha, those Egyptians were clever.
Yes. Now, this is the oldest version. Sundial is, it's a circle or half circle. And what you do is it has lines going out radially, and you stick a specific stick, or a vertical pole in the center of it. And depending on where the shadow lies, depends on what time it is. You point it north and then you put the stick in there and you say, the shadow is here. It means it's 3 o'clock. It means it's 4 o'clock. So this one is actually the oldest one they found in a excavation in Kings Valley in Upper Egypt. They were able to find this flattened piece of limestone, which has a semicircle in black color drawn, and then, divided into 12 sections with a dent in the middle for, a wooden or a metal bolt that would have cast the shadow. And then small dots in the middle of each section actually were able to provide even more detailed time measuring. Now, it was found in an area where there's some stone huts, so in about 13 BC. And so it's probably worked to house men working on construction of graves. So it may have been a time clock. You go to there and you're like, I worked from this time to that time. So very, So it would have been useful for that. Or possibly the division into hours. There's a very crucial role in their, netherworld guides, finger quotes in air, that were drawn on the walls of royal tombs. So it may have actually been used to sort of calculate very closely about the rules and what they needed to write up on the walls to kind of chronologically describe exactly what was going on, the night's progression, the sun god, hands wave in air.
We've been counting for a while is what you're telling me.
Yes.
Look at us go. I'm so impressed with us.
People want to know exactly how long they've worked and how much they deserve from their time.
You know what?
For a very long time.
Yeah. That is really, truly what it is, isn't it? Is you've got to have a way to account for things.
Yes.
Well,
now, it could have been a way to account for, the drawings on the graveyard, the tomb walls, but I like to think there's a little bit of those workers going.
So
hey.
the old saying, time is money, might be older than we realize.
Yes.
All right, Heather. Well, the SciByte 2000's flashing at me here. I think we have an incoming... Oh, we do have a little incoming communications, don't we?
We do.
All right, so what would we get this week?
Alrighty. Carl Sakritz actually sent in it wasn't a question, but it was like a little news blurb. Estonia is actually going to send up their first satellite, the CubeSat. We've talked about these before. These little cubes that, go up and pack in groups off, sort of piggyback off rockets, or sometimes a whole bunch of them are delivered in one.
Yes.
It's like everybody chips in and it's not so expensive. And this is actually, so the entire country's first satellite is going to be one of these. And it was actually made by university students.
No kidding.
Yeah, so it's the standard for these nanosatellites. It's sort of specific sizes and weights. So they had to work in a very closed in sort of, you must be doing it. Everything can't take long, much bigger than this.
Ooh. Yeah.
So what they're able to do is actually, they're going to be doing a little solar sail.
Oh, wow.
A solar wind sail.
It's actually much smaller than I even realized. It's not much bigger than, a Wii Cube. I mean, a Nintendo, the GameCube. It's smaller than a GameCube. It's tiny.
Yes, it's very tiny.
It's even it's even smaller than that because that's just the case they're putting it in.
Yeah, I mean, you could hold it in two hands. What was it? And one of the videos, one of the guys is holding it, and I think somebody was like, "All right, I had to take this from one lab into the other," and that was the scariest 2 minutes of my life, because you're handling your country's first satellite. Mm-hmm. This is it.
The people have been working on for who knows how long.
Yeah, how much? All right, I have done this. I have worked. Everyone has worked on it. This is our one go. I cannot drop it or we're doomed.
This is another reminder of kind of how early we are into this technology. Like, it's kind of a huge deal that we've gotten something this portable and this cheap and this modular, but it is obviously still very restricted in what we can do. But it's a very awesome first step. But in 100 years, this is going to look awfully quaint.
Well, of course it's going to look awfully quaint.
It's just this is a nice little reminder when you see this. I mean, these guys, this and I think we've actually talked about this. Some of these run Android. They're essentially almost like smartphone components in there.
Oh yeah. Now this one is specifically, it's using to educate the students, but it actually has some fairly significant scientific purposes too. Mm-hmm. They've got these solar wind sail created by this Finnish scientist. It's going to be the first real experiment of that type. They're going to be able to, measure altitude, an onboard camera for, taking pictures of Earth and watching what's going on. So essentially they have this little guy, and it's going to, it has a little 20 micrometer thin wire. It has a really thin wire that they're going to deploy from the satellite. So then it'll sort of string itself out, and that will slow the satellite's rotation speed.
So it's like on a tether? It's like
it's essentially
surfing
going
in space?
to, kind of. So
that's interesting.
Yeah, so they're able to see how fast it's spinning. They have this very specific rate of spin, and they'll send out this little tether that's actually it will be picking up the electrons. So it can interact with the plasma surrounding the Earth. And that interaction will change the spinning speed of the spacecraft. So it has, a little electron emitter gun, so that will connect to the element, and that'll shoot off electrons that it loads onto the element, about 500 volts. So then that will be able to push the plasma in the element. It'll have an influence on its rotation speed. And then they'll be able to measure that change in rotation speed to get data from how strong the plasma or the particles are interacting. And then they can use the camera to both take pictures of Earth and kind of look back at itself and say, okay, yes, we see that the wire is actually deployed. We're okay. So they're sending it up on this rocket in actually this spring, this year. So half hour, it'll start throwing off its antenna, its radio transmitter. Then a couple days a week, so it'll actually be testing. It'll do the, working to its full capacity. Then they'll kind of orient it so the camera will actually be able to face Earth, and they're going to try to take a picture of Estonia. It's their satellite. They're going to be like, all right, we're going to try to take a picture of our country. Then they'll rotate it at about.
That'd be big. That'd be in the paper. That'd be on all their big news outlets. It's our first. We took our picture of ourselves. Here we are.
Yes.
Yeah.
Well, everyone wants to do that. You send something up into space and you want to take a picture of yourself.
Right.
I mean, people on Earth. You have a camera. How many people turn around and take a picture of themselves?
Yeah, in fact, the new Samsung smartphone includes a feature when you take a picture of something to also use the front-facing camera to take a picture of yourself.
Yes. And this is like space.
Yeah.
So
yeah.
Lots more people would want to do that.
Understandably. Well, thank you to Carl for emailing or contacting us. Now, you can email the show, SciByte at jupiterbroadcasting.com, or maybe even better is contact Heather on Twitter. Go over to Twitter, and she's JB_Mars_base. And if you can keep it within 140 characters, you can probably get a question to her.
That is right.
All right, Heather. Well, then I think we have a story that's leveling up with some updates.
We do. The space shuttles, they're retired.
Mm-hmm.
Some of them are getting ready to actually open their exhibits. The space shuttle Atlantis, it's kind of plastic wrapped to protect it from construction debris.
Good.
It's at the Florida Kennedy Space Center complex, and it's going to open in June. So it'll have big payload doors will be open. They'll have the Canadian arm, a replica of the robot arm installed and extended.
They have like a DVR here where I can go back in time and look at pictures of it.
You can see it from let's see, what did it look like in December?
Kind of, it looks the same, wrapped in plastic. Yeah,
go back in December and you can actually see the back wall is sort of not there or sort of just now being built together.
Yeah, exactly. Yeah, that's awesome.
Because they had one whole wall that wasn't there. They roll the space shuttle in, then they build the wall behind it. Now this thing is going to be 30 feet off the ground, tilted at 43 degrees, so it's tilting it's coming back to Earth on the orbiting Earth as it's approaching the International Space Station. So one tip of one wing will only be 7.5 feet above the floor, and the other wing on the other side will be 87 feet above the ground. Then they'll have a replica of the Hubble Space Telescope. There's ways that you can, they've got two levels. One, you can be underneath it. One, they've got a second story. You can kind of walk around it and be able to see it. But getting closer, and they're starting to get the exhibit I think now it's really starting to pull together. So hopefully in June we'll have another update, and we'll all be jealous of the people in Kennedy Space Center that they get to peer and goggle at it.
Maybe one of these days we'll have a big beneficiary donor to the SciByte program that'll send us to do an on-location SciByte there underneath the wing. Under the wing, it's SciByte.
Yes.
Yeah.
If anybody feels like doing that.
Absolutely.
No pressure.
In the meantime, we've got a spacecraft update. Little SpaceX news?
Yes, they have this Grasshopper Rocket, and it's big 10-story tall rocket.
Okay.
And the plan is, they all go up straight in the air. Now, this one, they want to be able to come back down and land straight up still. They don't want it to fall into the ocean or tip over.
This is one you talk about. Didn't they try and it blew up? Didn't they? We've definitely seen ones like this that have blown up.
Yeah, they had one very early that had a blow up. Now, they had a couple of successful flights. This is a 10-story tall rocket. Now, back in September, they flew almost 8.5 feet up and landed back down.
Okay.
In November, they're able to go almost 18 feet and come back down. In December, they went 131 feet or 40 meters. Now they have actually gone 24 stories. So it's a big 10-story rocket. They rose it up 24 stories up, and then they're able to hang out there for about 34 seconds and then come back and land going straight down, really accurate, more accurate than they've ever done before. And it's kind of funny watching the videos. It's like you're watching it go up, and then somebody like pauses, and it's almost like they put the video into reverse.
Yeah,
it's like
it very much does seem like that.
Up,
Yeah.
down. Like the only thing that you like really convince yourself that it's not going in reverse is that the dust doesn't like all suck back up.
Right, and the flames are different and stuff. But
yes.
that's pretty fascinating. So they're just gonna keep not inch by inch, but by goal, going further and further until they clear the atmosphere and can land. Is that that's the long-term goal, right?
The long-term goal is this will be a first stage rocket. So you'll have sometimes rockets come in various stages. They'll stack on top of each other to get you higher and higher. First stage will get you up, to 2 miles, and then the next stages will be, pushing a much lighter load, and they'll have to just fly a little bit farther and a little bit farther.
Mm-hmm.
This would be a first stage where it gets it up pretty high into the atmosphere. Then it'll come back down and land vertically still. The plan is then you'll be able to reuse it completely as is, maybe a little bit of, tweaking, refurbishing. But so they're hoping that this will eventually lead to where they can actually test it and put something up into orbit, and then hopefully this will land and they can use it again.
Yeah, I mean, that's got to dramatically reduce the cost.
Yes.
It's a huge difference.
Oh, yeah.
Very cool. All right, Heather, well, while we're talking about spacecrafts, what do you say we do a little curiosity update and blast off to Mars?
Let's go.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
Oh.
Gosh, remember when we landed this awesome robot on Mars? That was cool.
Yes, I do.
Okay, so what is Curiosity up to this week?
Alrighty. We actually got the first Joule sample, and it's gone through. They were talking about, they see that it has water. They see the minerals are there, that they contain the ingredients to sustain life. Now, the big deal was we've seen water on Mars. We know it's there.
Mm-hmm.
What they were really excited about is that it was clear water. It wasn't salt. It wasn't very salty. It wasn't very acidic. That's what the other rovers have mainly seen. The Opportunity rover, who's still trucking along after all these years.
Right.
It's seen sort of water, places that have kind of been wet, but on an intermittent basis.
Yeah.
So it's wet, and then it was dry. They were very acidic and salty. Now, this location actually shows that it was wet for extended period of times with water, as one of the scientists said, you could drink.
So you could bottle that and sell it for a premium, and then we could fund missions to Mars by selling bottled Mars water. We call it Modder, right? Modder.
Okay.
What do you think?
Blink.
Okay.
Look to side.
All right, we'll workshop it off air.
Okay. we'll go with that.
Okay.
Everyone say, "Aw, Chris, that's cute."
Well, that's actually, though, what it tells you is that, while I'm making a joke, you could potentially land something there and get some good, decent water, right?
Oh, yes, you can. I've done experiments on that. There's water in the soil. It's 12% in some places, which is about the same, much water as deserts, but it's definitely there. But they're able to see, all the little bits and pieces that could be for life, and then it's water there, so
yeah,
we'll see.
I mean, obviously, it's not too surprising that different areas of the planet would have different types of water, but it's one of those things where when you've only seen the stuff you can't really take immediate advantage of, it's kind of like, okay, well, there's probably some good stuff somewhere, but until you actually find it, you don't know for sure.
Yeah. One of the other things is they have this big image mosaic now. They're able to take, some from the mast cam, attach the mosaic of all these dozens of images to see the mountain that they're kind of aiming for. In a lot of these pictures, you'll see, like, if they don't look very, quote unquote Mars-like or very dusty. It's because they have two different sets of images. They said the raw color, which is essentially like you were sitting there and you picked up your phone or your camera and you went click. And that's what it is. Now, they also have the whites balanced, which means they sort of as they really do balance all the colors again.
Actually,
so it was like,
I mean, I don't mean to get all science on you, but it's I think almost reverse. So they get an immediate picture where it's kind of like the like they just have like this basic like a JPEG, and then they have a raw version that takes longer to transfer, but then they can adjust it appropriately to have things more properly represent the color they should be, right?
Mhm.
Okay, so
Well,
it really
yeah,
is kind of like a high-end digital camera where it'll take two pictures, and one of them is the smaller one.
Mhm.
And, it's kind of like, I don't know, it's kind of quaint because in a way that's what my dad's camera does. And he's like, yeah, here's my RAW and here's my JPEG. And the RAW is 24 megabytes and the JPEG is 2 megabytes.
well, then it works. That idea for, when you're dialing, everything home, it makes perfect sense. You can get a quick picture of all the,
Right.
a quick glance at all the pictures that are coming in.
Well, and just it
You're
tells
like,
you, hey, we
okay.
took a picture of the right thing right away, right?
Yeah.
So,
And then if you want to, you can go back and you're like, all right,
Yeah.
actually give us the high def resolutions of these 10 images out of the 12 you took.
Right.
And
Don't
then,
even bother
boop.
sending the crap ones.
Yeah, you can skip other ones. And then they were able to, balance it out so that it would look like it was like if it was here. Like if you scooped up that little part of Mars and planted it in the backyard of NASA, the scientists could look at it and say,
You mean on the
that's what it
Mars
looks
set?
like.
Right.
Yeah.
On the Mars
So
set.
they can kind of glance at it and see, picture-wise, color-wise, how exactly things how work.
Right.
So they'd be able to identify things a lot faster. One of the other things that I saw just today is they had a little bit of another little tweak
Glitch?
in this. Yeah, a little glitch.
What happened?
It was some little file that they were able to identify it really quickly.
Doom
kind
3.
of, yeah, they're able to block it off, ignore it, say, all right, kick that to the curve. Everything else is fine. So it's just kind of on pause for a minute.
It went into safe mode, huh?
Yeah, it went into safe mode again.
I love that it's
Now-
tweeting, though. It says, don't call it a comeback. I'm just out of safe mode, and I'm ready to resume my science operations.
Yes.
It's tweeting. Not
Yeah, they
really,
have a little
right?
tweet
There's
for
a
it.
person doing that, right?
Yeah. I mean, it's got lasers and jetpacks.
I kind
But
of
it's
want.
too busy for a Twitter
I
account.
kind of want to live though in a world where it literally could tweet from Mars. It seems like that maybe like the next rover, maybe they could do that.
Maybe, but I'm pretty sure you were frightened of the jetpacks and the lasers to begin with.
That's true, but then again, if it's tweeting, I'll have an idea of when it starts to turn
Of what it's
against
up
us.
to?
And when it's coming back after it's learned the truth, whatever that might be, and it's using its rockets and its lasers and its nuclear reactor. If it's tweeting on the way back, yeah, I'll know. I'll have like a heads up
Okay.
that I need to start building a bunker because it's going to take it like a year to get here.
Uh-huh. I casually mentioned all the lasers and jetpacks.
And reactor.
And the reactor. That's because
And the
when it
science
landed,
chamber.
it didn't do the balloon bounce that other rovers has done. It actually got lowered on a tether from
By
a
a-
jetpack.
By a crane, yeah.
By a little jet crane on a jetpack.
Right.
Sort of. Then it left it off, and it has a little laser to shoot at rocks and stuff to vaporize some of the rocks. So you can get chemical analysis from there, spectrographic analysis. So
Yeah, you saw that the Russians and the Europeans are talking about sending over a rover that's going to bounce land. Did you see that?
Oh no, I hadn't. But
Yeah.
that is definitely the most common way
Yeah.
successful way for it
Yeah,
so far.
Russia's going to provide the rockets and the landing, and that's kind of cool.
Yeah.
All right, Heather. Well, very good. Now you've got a link to the Curiosity rover report, and if you're interested in following this thing, check that out because they don't have Mohawk Guy in there. I mean, I'll give you
No,
that, but it's still a really good.
Everyone gets their turn.
It's got the best of the best visuals in there with some really nice, clear explanations of what's going on. And if you want even more than what Heather's covered, she's got links to that in the show notes. But with that filed, Heather, what do you say you jump in the time machine and we'll go look back in science this week? You ready?
Let's go.
Let's go. Oh,
Okay.
here we go. Whoa.
Yeah.
Wait a
Smooth
minute.
ride.
Wait a minute. We didn't need the time machine for this. We could have just taken a Volkswagen. This is only 12 years ago. I don't even know why I bothered firing this thing up. So this takes us to March 23rd, 2001. 12 years ago, Heather, what happened this week in science?
The Russian space station Mir ended its 15-year in orbit by burning up in the atmosphere on its way back down.
I remember this
Yeah,
because I'm
it was-
old.
you're not old because I
It
totally remember it too.
It wasn't that long ago.
No, it wasn't that long ago at all. So it launched in 1986. It had only planned for like a 5-year mission, Ended up being 15 years. And essentially they decided in the end that in like late 2000 that, all right, it's not in their great condition. The expense that it takes to keep it going isn't justified. They went up, docked a Progress tanker on there, commanded it to fire the rockets, lower it into orbit, cause it to re-enter. Some of it burned up. What didn't burn up fell into the Pacific Ocean between New Zealand and Chile. So, and they actually like made airlines like reroute around that whole area.
I was gonna say, it seemed like a pretty non-event, I guess, all in all.
Yeah, I mean, for these type of things, they have a far in advance plan. They aim it into a specific area of the ocean.
Yeah, sure.
And they tell all the international, flights zoom around this area during this period of time. Tell ships in the area, hey, avoid this. Watch out that their debris might be coming down at this day. So
when I because of my age, I think when I think of the Mir space station, it definitely predated the International Space Station, and I didn't really know a lot about it until one of the stronger scientific movies of our time, Armageddon, which featured a lengthy scene in the Mir space station. Heather, I don't know if you're familiar with this movie, Armageddon. Mm-hmm. It stars Bruce Willis, and they go to Mir, although they end up in the movie. Now, obviously, this is where it diverged from science. In the movie, they destroy the Mir space station.
That's where it diverged from science.
So, that's what I remember about the Mir space station.
Okay.
All right, Heather. Well, that's very interesting, boy. I do remember that happening. That was, wow, cannot believe that was 12 years ago. So let me recalibrate the SciByte 2000. That way we can look up into the sky this week.
Alrighty, this week we've got Jupiter at sunset. You can look to the evening, look high in the southwest at sunset. And it'll be moving more to the western sky later in the evening. To its lower left will be that red star Aldebaran that hangs out around it so often. And to the lower right will be the Pleiades star cluster. A little bit of a star smudge around there. And at about 11 p.m. local daylight savings, you'll see Saturn rising in the east to southeast and move to the high southern skies by about early morning. And that's all the other planets are kind of taking a break, hiding behind the sun.
Yeah. They're taking an early spring break.
Yes.
That's cool. I understand. It's actually been pretty busy, so now we gotta clear out the inventory. We've sold out, and now we have to restock with new planets. Yep. Get the new ones in here.
Yeah, the comet that was kind of there is kind of no longer visible. It wasn't as awesome as it could have been, but that's okay. We got a little bit more, and we've got another comet coming later this year that scientists are eyeing with glee and hope, and no one wants to say how awesome they think it may be.
Okay. But you'll let us know when we kind of get a hint, right?
Yes.
Okay. Very good, Heather. Well, I think that's our whole show, isn't it?
I think so.
All right. Very good. Now I want to make a special plea right here to have you join us live, because we always love to have more of you join us live and ask us the science questions as we go, bring up topics, and entertain our video version of the SciByte program. So join us live Tuesdays at 7:30 p.m. Pacific over at jblive.tv. And I know that's late, so if you can't join us live, you can always grab the show Wednesday mornings over at jupiterbroadcasting.com. But we always appreciate everyone who shows up in our chat room to join us live. Heather, thanks for the great show.
Thank you.
And thank you, everyone, for downloading and tuning into this week's episode of SciByte. We'll see you right back here next week.